welcome to Ladyada.
Hey everybody, and welcome to Ladyada. We had a bit of a late night tonight because we had a jam-packed weekend.
For good reason.
We did all sorts of stuff. We saw Dune Theater. We are so vaxxed up.
Yeah,
and,
we saw Dune. We went there with
fun.
Vance, and then Vance had this cool shirt. And then today, boy, did we have fun today.
Yeah.
So Neil Dash came by.
Yay!
Adafruit, and, we did some stuff. He brought by a 30-year-old floppy, and we wanted to get the data off of it. This is when Prince, artist formerly known as Prince, had all these floppy disks sent to journalists and more because they said, hey, name change, so this is what you're going to use from now on. And we wanted to get the data off safely. There isn't any of this on archive.org. There's articles about it, but we ran into Neil at the park, and we said, hey, let's schedule some time to get together. We tried everything, but turns out what worked was a very old Mac PowerBook 180 I had.
Yeah, this is HFS formatted, so it turns out that you actually really do need to have System 7 running on a old computer with a floppy disk, but it popped up and it worked fine.
We got it. So it's 2 TIFFs, and what's amazing is they were distributing 3040 pixel by 3232 pixel at the time, and at the time it was Monday, July 13th, 1992.
Yeah.
And
that's when the file was. It's the creation date's wrong because this is before we had, I think, creation and modification dates. So the only date on there is the last modified date, which is 1992.
So we're gonna put this up on GitHub Archive. We're gonna do a blog post. We're gonna team up with Neil and do a bunch of stuff in addition to this. But this was super fun, and thank you so much, Neil, for coming by. I've known
you got the purple turtleneck.
Came in, dice to the socks. So let's kick off this show tonight, Ladyada.
Okay, so in honor of Anil, I'm wearing this EFF shirt.
Oh, yeah, he's on the board.
He's on the board. Giving Tuesday's coming up. EFF is one of many places, nonprofits that we recommend or we personally donate to. We think they're a good organization. But there's lots of organizations, so check out when we post about Giving Tuesday coming up in 1 week almost. Okay, so in between going to see movies, eating popcorn, and then feeling a little sick afterwards because I haven't eaten popcorn in a long time. We worked on some testers, so next week we are going to fab the KB2040 or RP2040 Pro Micro-ish board designed for people who want to make keyboards and they want to use RP2040, especially since CircuitPython has HID support. And we also have native keyboard support, like key scanning. And we're also working on asynchronous stuff right now. So this can make it for a very good, inexpensive board that can be used with keyboards. So let's go to the computer. I can show the board itself. So this is the board. It's got castellated pads, and castellated pads always kind of look a little bit weird because what we do is we put in oval pads and then slice them in half. We put the dimension layer through it. And so far, every board house has known exactly what we meant because we'll just put in the notes like castellated on 2 edges, and they'll do the right thing for us. That's nice. So we have to test all the connections, especially since this is a 0.4 millimeter pitch chip, and we do get a gold coat stencil, which really helps with the release of the paste. But still, we want to have a good tester, test all the pins. So far, our test code has done really good. We've sent out thousands of RP2040s. In fact, we're going to be doing a cool giveaway with the pink RP2040 feather boards this week, so stay tuned on Wednesday when we pop those into the shop. And then, so we're going to make a tester for this. So the testers, I think people have seen these. Can we go to the overhead? The tester uses uses a TNC 3.6 because I use the USB port, and thanks to TAC, we actually have code that loads the UF2. I don't use SWD because it's actually just as fast to just use USB. I actually literally mount this as a mass storage on the TNC and drag the UF2 file over, and that's much easier than messing around with a bin file because Arduino core for RP2040 generates a UF2 anyways. So the good news is that this is pretty fast. Oh, you can't really see it. Hold on. Let's try this again. Oh, it's so bright.
Super bright.
Well, you can see it had some text on before, but it takes about 3.3 seconds to test, and then once it's done testing, the little NeoPixel glows rainbow. And this is kind of nice when people get this. I'd like to have the NeoPixel on boards glow because it tells people the board's working and there's firmware running, which is a really good thing for people to know, because sometimes they're like, "Is my board bricked?" It's like, well, if it came and it has the rainbow glow, it passed test, it got code loaded onto it, so the USB port must be functional. It's gonna be something with your setup, usually a bad USB cable or a bad USB port. So as I was doing the testing, writing, so you have to write a lot of test code. Can you go back to the computer? So I read a lot of test code, and there's a lot of repetitive stuff. Like, for example, there is on the tester, there's an analog divider to test the raw voltage, to make sure that the raw voltage on the raw pin is at least 4.6 volts or so. It's the 5 volt output with, I think, a diode, so it's going to be 5 volt and then dropped a little bit, so it's 4.6, because there's a little bit of that voltage drop on the protection diode. I also do another analog test, and you're testing the analog voltage. First you read the pin, and that gives you an int, and then you have to multiply by the VRAF, which is 3.3 volts in this case, sometimes it's 5, and then you divide by the bits, the least significant bits per read, which is 1024 usually for 10-bit, but on the RP2040 it's actually 496 because 4096 because it's 12-bit. And then you multiply by the AREF. I don't know if I mentioned that, but basically you have to do a little bit of math to get that voltage from the pin. And so I kept copying and pasting this code from tester to tester, which worked totally fine, but was a little bit annoying because it's it kind of made the code a little bit clunky. And I was like, oh man, I got to the point where I was like, I should have a library that does some Testbed help stuff for me, because I have such common requirements. So I published a library. It's not in the Arduino Core library manager yet, but it's on GitHub. So for example, so stuff like scan I2C bus. This is a common thing I have to do. I have to detect, before I initialize a sensor, I want to just check, does it even appear on the I2C bus? And I can, that way I can, or if I'm doing address checking, I sometimes short the address pins to power ground and then reset the chip, and then make sure that the address incremented up or down or whatever. So having a little function that just does the thing where it does the begin transmission, check that there's a delay, and it returns the whether or not it found it. So that's such a common thing that I was doing all the time. So now I have it. Again, it's in this class. It's kind of a static function, except that I can configure the I2C port. So that's another thing. There's always little details what if I want to change the I2C port? Or a common thing is, if the I2C scan failed, I want the tester to say what addresses it did find. So I have another helper function that it goes through and it prints what was found on the I2C bus, which is a good debug thing, because sometimes my math is wrong. It's I thought I was doing address 2, but it's address 0. So it saves me a couple minutes, because I just call this right after the failure. I have stuff like read an analog voltage, and it does the thing where it divides it by the bits and it multiplies it by the AREF, and there's a multiplier because there's a divider, and it does all that little math for you, and it just wraps into a function, and then I can have a prettified test analog voltage function that it'll print what the name of the thing it's testing, and then what voltage it's supposed to be, and which one it did find, and it's within 10%. So just making it a little bit clearer and easier. And then my really common test pins function, which is it tests the 2 pins are shorted, and it also checks all other pins on the board to make sure they're not shorted. So it's kind of my basically GPIO test without having to do any sort of JTAG boundary scan type stuff. It's literally I just short 2 pins that are not mechanically next to each other on the chip, and then I verify that no other pins are shorted to it. That's a great way to detect shorts.
Okay, question. Does the test firmware have console ripple output?
It prints a serial port, right? Which is how, I don't run CircuitPython for test code, because CircuitPython, while wonderful, I want something very, very small and very, very fast. And that timing is important for tests. I need to have it boot immediately and test immediately, and I don't want to have anything in a REPL. So it just prints the serial port, and then in the tester code over here, like this is the teensy output, it reads the serial data, and whatever it is printed out, it displays for you. So you see that what would normally be on the USB serial port is displayed through the teensy USB, kind of like USB to USB. Which is why having two USB ports is kind of nice.
Okay. All right, what's next?
So that's the test bed code. So I'll be adding more to it. I'm adding as I redo testers. Often we have to redo them. I'm going to throw more and more stuff in here to make it easier for me to all the little shortcuts, and it should make all my test bed a lot easier to program. So we have nice code here where it's just like, I just do test pins, and then my test library is my test example sketch is quite short, which is kind of nice. Another thing is it has like a little NeoPixel helper. Like I often have one NeoPixel on the board, so I just call like set color, and it will do like setting the pin, and it sets the NeoPixel and does the right, and it kind of just shortens everything a little bit. It'll just shortcuts, so that's good for me. And then so the KB2040 will fab tomorrow with luck if everything works out. I want to see, this is actually how we internally track a new board. So I've got all of the components listed here, and then how many we have in stock. So we have 1.5 million 10 microfarad capacitors. Now that sounds like a lot, but it actually isn't. We go through a lot of 10 microfarad capacitors. A lot of boards have 5 or 6 of them. We're fabbing thousands of boards a day. So we easily go through, 10 to 50,000 10 microfarad caps per day. Header and switches, and so you can see all the components that we have that we're going to be using for this build. Another thing is, of course, we stocked up on as many parts as we need for the next quarter, because we don't know, especially with the Chinese New Year coming up, it's going to be hard to ship things around. It's hard to get parts. So we've got everything. And then if you sort by, quantity, basically we can make up to 720, which is common. I usually order about 600 to 700 PCBs for my first batch of PCBs, and we fab 250 for the first run. I found that 250 is exactly the number that if you have to rework a board, it isn't terrible, but it's enough that we can make sure that we get into the shop, and then people have a chance to pick up a couple. So that's the upcoming board. So I thought next up we would go into the great search, unless there's a question.
We will. One thing I got to do though is I didn't get the great search question into the thing I had to get it into quite yet. So I'm gonna do that now.
That's okay.
I'm gonna do that now. And while we're warming up for that, here's what's going on this week, everybody. So we're gonna have a weird week this week.
It's a weird week because it's a short week. Don't forget.
Sort of. It's a long week for us. So here's what's happening for us this week.
Yes.
We are Tuesday, we're volunteering at a food bank to get food to homeless shelters for Thanksgiving.
Turkeys.
And then Thursday, we're going to visit a Adafruit employee who's in the hospital. They're okay and everything. We just don't want them to be alone for Thanksgiving. So that's going to be on Thursday. Wednesday is a normal show, so don't worry about that. Show and tell.
I think JP's out this week.
Yeah, I think it's either us or Noah and Pedro for show and tell. I'll remember that later.
Live shows are minimal this week.
And then there's nothing Thursday and nothing Friday.
But you should be enjoying your turkey, and if you're not an American, well, have some turkey anyways. The turkey's okay to have once a year.
I don't know about that, but I do think that you could always play the shows. They're always online.
Okay.
So let me show the great. Let me get this thing ready here.
Okay, get ready.
I think it's ready.
That's cool.
I'm gonna get it in 1 second. Sorry, everybody. I gotta do a couple odds and ends here live.
Okay. While you're waiting, post your favorite Prince song in the chat.
Okay, you ready to do the great search?
Yes.
Okay, here we go.
Where in the world is that part I need? The great search with DigiKey.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116,
The Great Search brought to you by DigiKey and Adafruit every single week. Adafruit and DigiKey show you how to find the things that you are looking for, and that is something really important, especially now. Ladyada, what is this week's Great Search?
Glad you asked. This week we had a request. Email came in. Somebody was asking for 1206 sized warm white LEDs. We use them in our LED sequence. That's product number 1758. And they're like, I just want to use these, and I don't want to desolder the LEDs because that kind of sucks. So can you just buy it on reel? So we don't sell SMT warm white LEDs on a reel, but the good news is that DigiKey has like thousands of LEDs, and we've done some high current output color neutral LEDs, but we didn't do this particular thing, which is like an inexpensive, diffused-ish 1206 package warm white. So let's go to the computer. I'm just making some jewelry. So if you go to DigiKey, so white LEDs are kind of interesting. They have two locations they show up in. But let's just search for 1206 LED because that's kind of, whatever. We're looking for the size of the LED. So again, there's white and discrete LEDs. I'll say look in both, but in this case we're going to look in discrete. We want one LED indicator. And there's a couple different colors available, and there's millicandela. There's a lot of options. But the most important thing is we did pick 1206. So let's go for color. Of course, LEDs come in all sorts of colors, but we want white, and particularly we want white warm. I will say, what is cool, neutral, and warm? It really does depend on what is your definition of. I mean, I know that there's probably some formal definition, but 6,000K, 3,500K, and then 2,000K, I think are usually the three kind of boundaries. But of course, if you want to be more specific about color binning and how warm you want the LEDs, you can look at the data sheet and be more specific about that detail. For stuff like the LED sequence, it's not really binned or formalized. These are very inexpensive LEDs. So just be aware, there's times where you're I need it to be exactly this temperature because I'm using it for illuminating something that needs to have a full spectrum or a neutral light. In this case, it's just decorative. It sounds like this person's doing a decorative project. Okay, so applying this, there's a lot of options that come up, I will say. However, again, there's white LED. A lot of these, if you want to know what is the color, it doesn't necessarily here it's actually described as cool white, and of course in the data sheet you can get more information, but it's not the wavelength. The color. There's a lot going on here. So the color here, white, is generic and doesn't necessarily indicate that it's a warm white type LED because, again, usually the Kelvin warmth of an LED is only used for LEDs that are illumination, not indication. So bright LEDs. That said, as I was looking, this LED popped up because I was well, what if I actually do say I only want warm white and I don't want to dig, because I wanted to get this person to answer really quickly, and I was I'm not going to dig through every data sheet. So I clicked warm white, and the thing is that only one thing came up, but it was actually a pretty good option, which is weird, right? Usually there's you have to sift through things. But this is the warm white LED. It's a little bit, an unusual package. It's not the flat, but I kind of it's a little bit of a bar shape. And it's 1206. It's quite bright, but that's okay. It's 2700 millicandela, which is a bright. It's actually illumination LED. However, that's good. Just the choke resistor you use, just make it a 10K. It's you're losing less current, so good for everybody and everything. And it is cataloged as a warm white, and best of all, there's a lot in stock. So, it's 100,000 in stock, And the pricing is like pretty cheap. It's like 3-4 cents a piece if you're buying in quantity. Even in small quantities, it's like 5-7 cents. So this is like, I was kind of like, this is kind of my pick. There could be other LEDs that are more in that, like, ziggurat shape, whatever, like the boxy shape. But if you don't mind having a slightly unusual looking LED, maybe it's miscategorized, but this LED would do the job. You don't need to, if you're using something for indication, you can use an illumination LED and just like underdrive it and it will work fine. So I think that this is my great search pick. Maybe not what you expected, but there's a lot of them in stock, and that's the most important thing right now. So.
One question was, why not apply in stock when you were looking up stuff earlier?
I didn't because this happened to be in stock. But yeah, usually, if it wasn't that I only had 50 choices, I would have. But I'll say another thing. The LEDs are not as affected by the silicon shortage. So if it is out of stock, it's somewhat likely to come into stock very quickly. Whereas with silicon, if it's out of stock, there's it's a mystery when you might get it. So I'm a little biased on some things, but also wanted to have something to recommend for long-term use. And this isn't my project. This is another person's project. So if there was a really good LED and it was out of stock, but it would be in stock in a month, I'd still send it over and say, hey, look, this is unavailable right now. I don't know what your needs are. If you can wait a couple weeks, this might pop up. So
Okay.
There you go.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay. So a couple quick questions. I answered these in the chat, but
Yeah.
yes, Ladyada wrote much of the software, some of the software, and none of the software of our internal systems. Some she did, some she worked with our team, and then some our team did.
Some of the very, very old original code I did, but I honestly,
Yeah.
I think it's probably been all yanked out by now because I'm
But that's
better at hardware than at software. Although it's funny, software people say I should stick to hardware, and hardware people say I should stick to software.
well, not our community. You're talking about jerks on Twitter. Okay, and then we fabricate thousands of boards a day. Yep, Monday through Friday.
Yeah,
easily 5,000 boards a week.
easily five, sometimes 5 to 10,000 boards a day.
Yeah.
Easily.
So, and I was putting in the chat, we ship
fast.
over 30,000 orders a month. That doesn't include AdaBox, which is every roughly 3 months now because it's gone to seasonal. Some folks really like how fast we ship. Thank you. And next up, any good suggestions for a USB hub microcontroller breakout PCB for Raspberry Pi?
I don't know. I mean, we have one. We have the Zero hub, but I would say just get a hub. You know.
All right. Some folks like Purple Rain. I mentioned the solo performance in the Rock and Roll Hall of Fame honoring. It was George Harrison, and they played While My Guitar Gently Weeps, and Prince did an amazing solo. Let's see. I think that is it. Good.
Okay,
Good disc of Ladyada.
keep it straight to the point.
Yeah. So, anyways, that's our schedule this week. Don't forget, Tuesday we're out, Wednesday show, no shows Thursday, Friday, but we'll be around. We're posting tons of stuff on social media. We're exploring New York again, and we're doing all sorts of fun things with people and going places. And what a great time and a great city. And thank you, everyone, for joining us and making this a great community and one of our favorite half an hour-ishes that we do every single week on Sunday or sometimes Saturday when we have stuff going on Sunday. This was the Desk of Ladyada.
Bye, everybody. Have a great week. Happy Thanksgiving.
Let's see, how do I get out of here?
Bye.
There's new buttons on this thing.
Oh, yeah?